Okay, so let's talk a little bit about the science behind MAT. People ask me all the time, what are we doing? Okay, I would argue that we're not really working on muscles. We are evaluating the central nervous system, how well it's functioning and how well the signals are flowing to that muscle. We're going to use a length tension curve here to kind of talk about that. This A stands for active tension. So that is a muscle in its shortened position and its lengthened position. We have very little tension on those two ends. Here in the middle is where we have the most tension. So what that means is here, there's not a lot of tension on this muscle. Down here, there's not a lot of tension. But if I were doing a bicep curl right about here, we'll start to feel that muscle engage, right? That's where we have the most tension. So this curve, P, represents passive tension. In a muscle's most lengthened position, the surrounding tissues like fascia are putting tension on the muscle. So when we are muscle testing, we want to be able to rule passive tension out. We want to look at N, neurological input. We have the most neurological input into a muscle cell when it's short and when it's long. Now, when we're testing, we want to rule out passive tension as much as possible, take that out of the equation. We want to go with the active tension. And if that cell is not receiving the neurological input that it should be getting, then we're going to get a muscle test and it's going to show us that it's weak. It's very easy to identify a weak muscle here in its most shortened position. And so that's what we're evaluating. And in another video, we're going to be going through a little bit more of the science behind MAT and how it works.